Welcome to Panasonic Campus Munich, to Microelectronics Demo and Application Center. We promote here our flip chip bonders, die bonders, plasma cleaner and plasma dicing equipment. We have here analytics equipment for cross sections, drop angle measurements, plenty of microscopes, shear testers. And my name is Bernhard Oberhofer and I will guide you through the application which we want to show you today. Now we are standing in front of the plasma cleaner PSX307. I would like to explain you some functions the machine has. So the machine is available with different chamber sizes. For example, 3 liters and 4 liter. Difference is the plasma density is higher on the 3 liter chamber versus the 4 liter chamber. The machine can be equipped and functions with up to 2 different gases, where normally we use argon and oxygen. Other gas mixtures are also available optional. The machine is also available for different transport variations, where our current machine is equipped without any transport system. So you will see today's actions all manually, but the machine can be delivered with full inline capability or magazine to magazine transportation. Before showing you the tests, the machine has been calibrated in vacuum leakage, in stability of gas flow and stability of RF signal to activate the gases to a plasma. After I have showed you the specifications of the plasma cleaner in front of it, we are now in the analytics corner and we have here a drop angle measurement equipment with 2 syringes where we use pure water and diiodomethylene. With these 2 liquids we will calculate the drop angles and finally the surface energy. To start, I will utilize a fresh substrate without any plasma treatment and check the angles. I generate a droplet of water, transfer it to the substrate, and the system measures the angle 10 times and saves it in the database. Here they are. As a next step, we use another location and transfer the liquid, the second liquid. Same thing we do here. And measure it as well 10 times. Done now, and what we see is that we have an angle of about 80 degrees with water and about 30 degrees with diiodomethane. After having the values from before plasma, we would like to do the plasma cleaning and come back after this. Before we start with our today's surface modification, I would like to check if the machine is well calibrated. Therefore, we have under maintenance a matching tank function which would give us some good picture if the machine is calibrated well, whereas I can explain you in parallel the functions. Here we can see our recipe, which I just prepared before, where we have the 2 gases connected to the machine, argon and oxygen. For surface treatment, I have decided for 100 milliliter of oxygen per minute. Another recipe parameter is the degree of vacuum which we want to generate before we start the gas flow. I set to 20 Pascal. And the RF power with which we activate the gas to generate a real plasma. With 20 seconds programmed here is the duration of the whole plasma treatment. And at 70 Pascal we ignite the plasma after we have reached a stabilized pressure when the gas flow has started. Let's do this by pressing the start button. Chamber closes and the various parameters of the plasma cleaner recorded are shown here in a nice graph. What you will see is that the orange line will represent the vacuum, so it comes down to the value of 20 as programmed in the recipe. It goes up when the white line is added, which represents the gas flow has started. Then it comes down again, and here the yellow one has started the RF signal to activate the real plasma in the chamber. After the 20 seconds have elapsed, the RF power will be switched off and the chamber will open. There are some other parameters shown here in the graph, and the outcome looks good to me that we are ready now to proceed with the real cleaning of the substrate for today. Here we are at the full manual menu. I put the substrate which we want to treat into the chamber. I place it on the bottom electrode and close the chamber. This is a recipe we know already, and this is what we wanted to start. By the way, you also can program a second step just in case it would be necessary to have two different gases followed by each other to improve your individual process. Let me start the cleaning. Chamber closes, shown by the position of the valve. The evacuation has started. The pump is continuously evacuating the chamber. The vacuum gauge has opened and the pressure inside the chamber is shown. It will be pumped down to 20. Then you will see that the oxygen gas will open. Now, after coming down again with the pressure to 70 Pascal, the RF will start and activate the plasma in the chamber. And then we have to wait until the time has elapsed. Our setting was 20 seconds. While the plasma is ongoing, we have a plasma monitoring sensor which is making sure that the plasma has really ignited in the beginning, and it also ensures during the whole plasma process that there is no abnormal discharge during the process, which ensures you quality and to your product. Meanwhile, the process has ended and the chamber is open again. I need to manually open my manual system and have the clean substrate. And with this, I can go now back to the drop angle system. Back from cleaning with freshly treated substrates, we have to perform the measurements again. Another drop of water as a first measurement onto the surface, transferred to the substrate. And start. What you can see in the picture already, that the angle has already lowered a lot. This is the purpose what we wanted to have. The measurement should have been done 10 measurements and we achieved 21 in average. Second thing is that we also have to perform our second liquid, diodomethylene. Creating droplet, transfer to surface, and starting the measurement. Started making the graph and having a result after 10 measurements of 17 degrees in average. That's exactly what we wanted to see, that our plasma cleaner is lowering the angles and generates a higher surface energy to improve your wettability of substrates. For example, underfill of BGAs or flip chips, for example. Yeah, later on we will show you as a stand picture the results of the measurement showing parallel together. Today we have learned a lot about improving the wettability on PCBs. We have seen low angles after plasma cleaning with our PSX307 and increased surface energy. Not just wettability is an option what we can improve, also with our argon plasma we can improve wire bondability, which would increase your shear strength. We would be happy to welcome you with your own samples here in our lab to show you our capabilities. Thank you very much.